Page 2, here is the lesson for 9.6 regarding growth and decay. So you can read this top part, but I'm not going to take the time. All I'm going to do is I'm going to pull out some of the important functions that it gives me. This first one is a times 1 plus r raised to the t. And the second one is y equals a times e raised to the kt, where k is a constant. And then the same thing for exponential decay. The only difference here is that we've got a minus sign in the middle. And then again, the constant becomes a negative constant of growth. So those are the important parts. You can read through those on your own. The easiest way to learn about exponential growth and decay is just to jump into some examples. So a computer engineer is hired for a salary of $28,000. If she gets a 5% raise each year, after how many years will she be making $50,000 or more? It says use the exponential growth model with the following. And even though it already gives me my knowns, I like to rewrite them so that I have them and for sure didn't mix anything up in the process. So my first known is that her initial salary, the amount that she starts out with, is equal to $28,000. It then says the rate is 5% or 0.05. It says after how many years will she be making that amount? So I know that she wants to be making $50,000 and I know I'm solving for time. It also then says use the exponential growth model. Well, because there's no constant of growth, I'm going to use the first equation that it gives me, which is a times 1 plus r raised to the t. From here, I can just plug things in. I know she wants to be making $50,000 or more. So instead of an equal sign, I can do an inequality here if I choose to. I don't really care because ultimately it just says how many years after. So if we get to that point, obviously after that point, she'd be making more than that. But for the sake of being mathematically correct, I'm going to put that inequality in. I put in the 28,000 for A, and then I put in 1 plus the rate, which is 0.05. Make sure you translate that into a decimal and don't put it in there as a percent. We don't calculate with percents. And then because we are looking for t, we're just going to leave it as a variable. From here, we solve by trying to get t alone. In order to do this, we just have to start moving things away. Start by dividing both sides by that 28,000. From here, we get 50 over 28 is less than or equal to 1.05 raised to the t. I just simplified what was inside there. Now, to get this t out of the exponent, what we're going to do is take the log of both sides. And what this allows us to do, and from here on in, I'm just going to use an equal sign so I don't have to keep remembering to use the inequality. But what that log does is it brings the t and it turns it into a multiplier rather than an exponent. That's just one of our exponential properties. And when I do that, if I want to get t by itself, all I have to do here is divide both sides by log of 1.05. When I do that, I get that t has to be greater than or equal to, I guess I am sticking with the inequality, of 11.88 years. So there's that one. Let's move on to the next one. So as technology advances, the price of many tech devices such as scientific calculators and camcorders goes down. One brand of handheld organizer sells for $89. So right off the bat, before I even know what I'm going to be solving for, I'm going to write that down. The initial price right now, before the problem's even started, is $89. It says if the depreciation rate of this organizer is 16%. I don't know for sure, but I do know that that's a rate that I'm going to have to use. Don't know for sure when, but know that I will have to at some point. It says after how many years will its price be $50? Well, that's an ending price, so I'm going to put it as y, and I know that I'm solving for t. Now, the reason that I underlined depreciation was because on this one, I'm going to be using the exponential decay model. And that one is just like the exponential growth, except instead of a plus 1 plus r, I have to do 1 minus r raised to the t. But from there, everything else stays the same. I still plug 50 into y, still plug 89, and then I multiply 1 minus 0.16 raised to the t. From there, I'm solving it just like I solved the one above. Divide both sides by 89, and I set it equal to 0.84 raised to the t. And all I did there was I simplified this piece down. From here, I'm going to take the log of both sides, and that allows me to bring my t, which is currently an exponent, out as a multiplier. So I get log of 50 over 89 equal to t times the log of 0.84. From here, to solve for t, I'm just going to divide both sides by that log of 0.84. And I want to show you specifically here how I'm putting this in my calculator, because I know that the calculator can be a little bit challenging with logs. So when I plug this in, I have to go to log here. So log of 50 divided by 89. Because that's the top part, I'm going to throw my parenthesis in there. Once I've put all of that in, I'm going to divide by the log of 0.84. And again, I'm going to close my parenthesis. This tells my calculator where to stop the logarithm and where to start the division. Doing this allows me to get the correct answer of t equal to 3.31 years. Basically, we have to always close the parenthesis with log. Sometimes we can get away with it, like if we're just taking the log of 7. The calculator doesn't really care about that decimal. But I want to show you what happens if I take the log of 50 divided by 89 and I don't put that in. This is telling the calculator to divide twice. So log of 50 divided by 89 divided by the log of 0.84. And actually, if we do that, it gives me a non-real answer in this case because this is too small. But on occasion, it will give you an incorrect answer because it's got too much going on here for the calculator to understand. So just be careful. All right, flipping over to the back side. Steve plans to invest $500 at 8.25% interest, compounded continuously. I've been talking about this in class, but I just want to remind you, anytime you see compounded continuously, we're going to be using the PERT formula. How long to the nearest month will it take to triple his money? So let's start with our knowns. If he invests $500, that's an initial amount. That is the amount that he put in. The rate, it says, is 8.25, but when we transfer that to a decimal, we get 0.0825. We obviously know the formula, but we actually know one other thing here. And it says, how long to the nearest month will it take to triple his money? Now, there's no number here, but this tells us our P, because we know if we started out at $500 that we need to end. And this one's a little hard because it's working with money, so this should actually be P. That our amount that we end with is going to be triple what we started with. So 500 times 3 tells us that we end with $1,500. We can now use that to plug into our formula. 1,500 equals the starting amount 500 outside of 1. PERT. I used my second formula, not my first. Ignore this, please. 500 times E raised to the R, which is 0.0825 T. Apologies for that little mix-up in the middle. I thought I was using my other formula. From here, it's the same solving. Divide both sides by 500, and we get 3 equals E raised to the 0.0825 T. Because I have a number on one side and an E on the other, I can take the ln of both sides, the natural log, And what that does is when I take the natural log of e, it cancels out. So I'm left with 0.0825t equal to ln of 3. Now to get t by itself, all I'm going to do is divide both sides by that number. And I'll show you how I do that in my calculator. ln of 3, close parenthesis, divided by 0.0825. Again, that parenthesis is very important. You don't want to be saying the natural log of 3 divided by 0.0825. You want it to be two distinct pieces in your calculator. When we calculate that, we get t is equal to 13.32 years. However, if we look at the original question, it does say to the nearest month. So if I want that to the nearest month, I have to take my answer and multiply by 12. Once I do that, I'm going to round that to the 160. So it's going to take 160 months for his money to triple. Again, make sure you're reading the question and what it asks you to put your final answer in, because this would technically be wrong on a test. That's not what the question asked for, so that's not how I'm going to answer it. All right. A certain strain of bacteria grows from 40 to 326 in 120 minutes. Given that y is equal to a times e to the kt, find k to the nearest 10,000. So this time we are going to use that second formula. I'm going to write down my knowns here. I know that I started out, my initial amount was 40 bacteria. I know I ended with 326 bacteria. I know that my time is 120 minutes. And I know that I am solving for k. And then obviously the formula is right there, so I'm not going to rewrite it. This is a tricky one because this one doesn't require us to put t in time in terms of years. This one we can plug it directly in and it will give us our answer in terms of minutes. However, when we're using PERT, that formula is specifically in terms of years, so we do have to be careful when we're plugging in numbers. All right, let's start plugging into our formula. 326 equals 40 times e raised to the 120k. Divide both sides by 40. We get 326 over 40 equals e to the 120k. Now that I have a number on one side and e isolated on the other, I can take the ln. I don't want to take the ln right here because e is not isolated. By isolating it, we avoid any mathematical errors from computing. So now I've got the ln of 326 over 40 equal to 120k. To get k by itself, I'm going to divide both sides by 120. And my final answer, when I plug it in the calculator, is ln of 326 divided by 40, close parenthesis, divided by 120. Let's fix that so it has a 0 on it. 120. So k is equal to 0.0175. And for a constant of growth there, that's pretty normal to have that small of a number. All right, the next one's a little tricky. It says use this formula where A is the initial amount of carbon-14, T is the number of years ago that the animal lived, and Y is the remaining amount after T years. It says how old is a fossil that has lost 95% of its carbon-14? And it says round to the nearest tenth of a year. Well, here we go with our knowns. I know my formula right off the bat is y equals a times e to the negative 0.00012t. And it says it's lost 95% of its carbon-14. Now that doesn't give us any numbers, it gives us a percentage. But from that, we know we started out with 100%. 100% as a decimal is just 1. It then makes sense that our final amount that we ended up with was 100% minus 95%, which as a decimal is 0.05. I know that's a little bit confusing, but if you think about it in terms of percentages, this says I started out with 100% and I ended with 5%. From that, I can just plug things in. 0.05 equals 1 times e to the negative 0.00012t. And from there, we're just solving. We've got a number on one side. We've got e isolated on the other. Technically, there's a 1 out front, but it doesn't really change anything. So I'm going to go ahead and take the ln of both sides. And I'm going to get negative 0.00012t equal to the ln, or the natural log of 0.05. Divide both sides by that number. I'll throw it in the calculator here for you. ln of 0.05, close parenthesis, divided by negative 0.00012. And I get that t is equal to 24,964. It says to the nearest tenth, so I need 1 decimal, 4 years. So this dinosaur in particular, or this fossil, is 24,964.4 years old. All right, last one. It says, how old is a skeleton that has 95% of its carbon-14 remaining? Well, our knowns all stay the same, so I'm just going to say these all come down here. The only differences are A still starts as 1 because we started with 100% of the skeleton, but now our Y, instead of losing 95%, has 95% left over. Now we can solve it the same way we just did with that one. 0.95 is equal to 1 times e. I'm not going to write the 1 in. To the negative 0.00012t. ln of both sides, and we get negative 0.00012t equals ln of 0.95. Divide both sides by negative that. And then I'm just going to calculate it. I'm going to pull this exact one down, plug in 9, hit equals, and I get that this is only 427.4 years old. So you can see there's quite a difference there between something that's lost 95% of its carbon versus it still has 95% of its carbon. But yeah, there is your exponential growth and decay. Remember, the best way to learn these is to practice them. Don't be overwhelmed by word problems. All you have to do, write down those knowns and take the word problem part out of it, so you're just working with numbers and letters. Let me know if you have any questions.